Welcome back to the lithosaber project. It's time to talk electronics.
I'm going to talk about the circuit for this project, which we're going to start with a breadboard and prototype and then convert into a full-fledged PCB.
To control the logic, I've chosen an ESP8266 on the node development board. I chose this primarily because it's easy to program over USB and it has a lot of pins available to us. Although that was another challenge that I plan to talk about later on.
Starting with the power components, the first obvious one to me to talk about is the battery, the power source for the entire circuit. I wanted to use a single cell just to keep form factor down. The next important thing to me was the protection circuits associated with it. I initially tried to look for external protection boards like the TP4056 and 7, but those have an over discharge protection, and that just means it won't let you draw more than a certain amount of current. In that case, it was about 1 to 3 amps between the options I saw. In order to drive our LEDs and the rest of the circuit, we're going to be drawing around 3 amps the entire time, and that would be really inconvenient for the entire circuit to shut off every time. I luckily found a cell that had an 8 amp over discharge protection, which is a little bit more than double the amount of current we're going to be drawing when the LEDs are at full brightness, but we definitely want to have that factor of safety built in. Now, all of this power from the battery is going to be drawn through a slide switch that will function as our power switch. And this is just the smallest switch I could find that was rated for a high enough current in order to use for this circuit. I also have this voltage divider circuit. It just lets you take an input voltage and read a scaled proportion of that voltage, which is important to us when we want to detect battery level using a pin on the microcontroller that only expects a maximum voltage of 3.3 volts. The output of the battery is then connected to the input of this boost converter circuit. This is me replicating a breakout board that I got from Amazon. So we'll desolder the components off of that breakout board and solder them onto the PCB that I make rather than buying new components. This circuit just takes the 4.2 volts from the battery and then uses a transformer along with a fine-tuning potentiometer to allow us to output 5 volts directly to the microcontroller and several of the other components. This 5 volts is not fed to the LEDs. The LEDs rather get the 4.2 volts directly from the battery. They don't have that 5 volt requirement. The important thing for the LEDs is getting enough power, which is why we don't pass them through this boost converter circuit. The components in this boost converter circuit are not rated for high amperage, so we don't want to fry them.
And then the remaining components, a display output in the form of an OLED screen, an accelerometer, a rotary encoder, an amplifier to drive our speaker, and then an SD card reader that allows us to store audio files to play over the speaker.